Alright, this video is a pre-lab for your diffusion lab. Specifically, we're going to be looking at the rate of diffusion. In your notebook, write your observation. The observation is the rate of diffusion seems to depend on environmental temperature. So your question, how does temperature affect rate of diffusion? Your hypothesis, which is an answer to the question, and your prediction, which is an if-then statement. Both need to be done before class begins. All right, what you're doing with this lab is you're going to have dialysis tubing. Okay, dialysis tubing. It is a very thin piece of cellulose that is a tube, but it just looks like it honestly looks like a piece of paper. But what you'll do is when you submerge the dialysis tubing in the water, okay, just in some water, and you rub your fingers back, your thumb and index finger back and forth with the tube in between, the tube will actually open up, and it's probably best if you do this underwater. Now, once the tube is open, you're going to tie off one end. So open tube by submerging in water. Then you're going to tie off one end with a piece of twine. You're going to fill the tube with a dextrose or glucose solution. Okay, fill tube with dextrose solution, and then you're going to tie off the other end. Now, there's some important concepts and techniques to tying off the end and filling your tube, because you want to make sure that your tube is actually very plump. Okay, you want it to feel like, honestly, you want it to feel kind of like a grape. So what you'll do is you'll twist the tube to try to get all the air out of the tube, and then you'll also tie it off so you could get it to be plump. You want it to be firm like a grape. You do not want it to be kind of squishy. You don't want to be able, like, if you're squeezing the cell, your cell is going to look something like this, and it's going to be tied off here with a couple pieces of string, tied off here with a couple pieces of string. You want if you have a finger here and a finger here, and you're squeezing them together, your fingers should never touch. In fact, they should not even get that close to each other. The cell itself is only going to be, I don't know, maybe literally, it's going to be about the size of a grape. So you'll want to fill your solution, so you're going to have dextrose inside the cell, okay, because this is pretty much what it's doing. This dialysis tubing is modeling a cell membrane. So inside the tube, you're going to have a dextrose solution, and then what you're going to do is you're going to submerge that cell in a cup. Okay, we can get rid of our fingers because we're not going to be doing that anymore. Okay, fix my cell, fix my cup, and you're going to fill that cup with water. And then we're going to see if water is going to be moving into the cell, or is water going to be moving out of the cell, or is the dextrose actually going to be moving out of the cell. So what we're going to do is we're going to determine pretty much the permeability of this dialysis tubing, as well as determining the rate of diffusion, whatever it happens to be, whether the dextrose leaving, or the water leaving, or the water going in. And you'll be able to tell what's leaving and what's coming in based on your data collection. Because what you'll do is, as soon as you're done with tying off the other end and making your cell, before you put it in the cup, you're going to need to mass the cell with the triple beam balance. Okay, so once you mass with the triple beam balance, you record your data, and then you're going to put the cell in the water, and then a couple days later we're going to take a look at the cell and mass it again to see if there was a change in mass. And there will be a change in mass. So what you'll be doing tomorrow is making the cell, and then you're going to submerge it in water. Now you're going to make, okay, this right here, you're going to make two of them. One of them is going to be at room temperature, and I'll let you know what that room temperature is tomorrow. It varies from day to day. Usually it's somewhere around 22 degrees Celsius. And then you're also going to put another one in an incubator. and I'll also let you know what the temperature of the incubator is tomorrow. But 1 cup is going to stay at room temperature, 1 cup is going to be in the incubator, and then we're going to see if temperature is going to affect how fast the diffusion is occurring. All right. The next time that we visit this lab, after you mass your cells, once they've been in the water for a day or two, we will then start doing graphical analysis. Okay, and we'll do some pretty easy math. Okay, just a couple division problems to and subtraction, just to find out A, how much mass was lost, and B, what is the rate of diffusion per hour. Okay, and then what you'll do is you'll graph that on a piece of graph paper, and that'll be a part of your lab report. And one last note, bring proper footwear.